Next, advantages and disadvantages of skewness. So here already we know that skewness, how can we measure the skewness? Kelly's measure, Bowley's measure, etc. measures we discussed in the skewness. Skewness is nothing but how the data is variated, okay, from the mean. So how is it framing the normal distribution or not? If it is not framing the normal distribution, how it is skewed, either positively skewed or negatively skewed, means what is the role, means what is the lane of the frequency, how it is going to be distributed is nothing but the skewness. Coming to the advantages of skewness, here first we will discuss identifying the outliers. Identifying the outliers means here when we are getting the frequencies, we are getting different frequencies. So from, for example, if you have taken the marks of a particular class, so from 10 to 95, the students may got the marks. So here we can identify the what is the upper limit of the frequency and what is the lower limit of the frequency. For example, in a class we have taken the 100 members of the strength, how much the 1 to 10 means 1 to 10 marks, 10 to 50, 10 to 20, 20 to 30, 30 to 40, 40 to 50, like that. Means we have taken a class interval, then the number of students will be there in the class interval. Then in that frequency means how much the frequency got distributed in which area is moving to, means what is the mode of that frequency, what is the mean of that frequency, what is the median of that particular distribution. All these things we will get because of this skewness. We can identify that what is the upper and lower limits of that particular distribution. We can easily identify with the help of this skewness. Means how that data is skewed. Then means how it is, when it is not asymmetrical, definitely it is going to be skewed. So how it is going to be skewed, we can identify from this what is that skewness definition, because of this identifying the outliers. And similarly, understanding the data shape. So because of the skewness, we can identify why, because here likely this is the distribution. For example, the distribution may be like this. For example, the distribution may be like this. For example, the distribution may be like this. Like this, here in different variations we will identify. So because of this skewness, we can identify the shape of the data, how the data got distributed. Either it may be in the normal distribution or it may be not in the normal distribution. If it is not in the normal distribution, how it is skewed. So we can identify that shape because of the shape of the curve. We can identify that shape of the data from its skewness. And similarly, assessing the risk in mostly financial terms while making the distribution. For example, if you consider the share prices of a particular company, so how it is going to be, for example, we will take analysis of the past 3 months analysis, how the data is going to be distributed. Because of that line, because of the distribution of the share prices, how it is skewed, either it may be positively skewed, then we can get the more returns. If it is negatively skewed, we will get the less returns. Based upon that, we can identify that share price movements. Based upon that, we can assess the risks. Mostly this skewness will be helpful in the what is that share prices regarding to identify the risks involved in the various shares of the markets, means according to the stock markets. That is different advantages we can secure with the help of this skewness. And similarly, we have some disadvantages, that is sensitivity to outliers. So because of, we can identify the outlier because of this extreme values. Why? Because extreme value means the upper limit of that particular distribution as well as lower limit of that particular distribution, that because of these extreme values are affecting the total shape of that curve. So because of that, we may mislead the results. Why? Because in a particular class, means the lower limit may be a 10 marks and upper limit may be a 90 marks. But by most of the students got the marks in between 60 to 70 or 50 to 60. But the distribution, the upper and lower limits will be there 10 to 90. Because of this, the curve may be in different way. The skewness may be different. Because of this skewness, we can, what is extreme values may affect the situation because of that sensitivity to outliers. Then non-invariance of transformations. So it is not helpful while transforming the data from one set to another set. So it is not invariance. It is not variation between these transformations. Next, all sample size dependency. Because I mean, when we are taking the sample size dependency, when we have taken the small samples, then obviously small samples may not give that accurate results. Small sample, based upon that small sample, that maybe we will get some result, but based upon that small sample we'll take the decision. It may be not perfectly what is that may affected in the large sample. nothing but if we have taken the population, but when we have taken the small sample analysis may not be accurate for the population. Because of this, the skewness, based upon the skewness, we can secure the disadvantages. These are all the advantages and disadvantages because of this skewness.